Hello and welcome to this required practical video all about how to find the density of different objects. We're going to start with the regular shaped objects and then we'll move on to the irregular shaped objects in a moment. So here I have two regular blocks, metal blocks, and we are going to find the density of them by calculation. So the first thing you have to do is measure your regular object. And we need to know measurements for its width, its depth and its height. So that's the first stage. So to find the volume of this cube, I'm going to measure using a ruler its width, which is 20 millimeters, its height, which is 20 millimeters, and its depth 20 millimeters. So it's 20 all around, I think, for both of these cubes. Really messy. Look at the skills though in drawing 3D objects. Mrs. Sutton, if you're watching, your lessons at secondary school weren't wasted. So here we go. There we've got our cube, and just to double check, I'll measure the aluminium block as well. Yeah, so that's 20, 20, 20. So now we have to just do a calculation to find the overall volume. So 20 times 20 times 20, that would give it to us in millimeters. If we're going to do it in centimeters cubed, it's going to be 2 times 2 times 2. So 2 times 2 is 4, 2 4s are 8, so that is an 8 centimeter cubed block. Okay, so off screen I literally just went and chucked both of those cubes onto a balance, and the aluminium has a mass of 21.1 grams and the zinc cube had a mass of 50.75 grams. So the calculation for finding density is the mass divided by the volume. Because our mass is going to be in grams and our volume is going to be in centimeters cubed, we are going to end up with a density in grams per centimeter cubed. Little tip, which I was amazed to find out when I did my A-levels, is that if ever you forget the unit for something, if you write down the equation and literally just put in whatever the units are of the things you're chucking into your equation, that will give you the units that you should pop out with at the end. So this is grams divided by centimeters cubed, so the units of density are grams per centimeters cubed. Test it out with a few other equations, it almost always works. So doing the actual calculation itself then, get rid of that. So for our aluminium block, our density is going to be equal to mass divided by volume. Always show all of your working so that the examiner can see exactly what you're doing. So my mass was 21.1 and my volume was 8, so I'm going to punch that into a calculator, which gives me 2.64 grams per centimetre cubed. For the zinc, my mass was 50.75 and I'm going to divide that by the volume, which is 8. Again, punching it into my calculator, 50.75 divided by 8, which gives me 6.34 grams per centimetre cubed. Do not forget to include your units, that is really, really important. Now the other thing, when giving your answers, be very cautious. My balance gave me my results to 2 decimal places, so I should really have put 21.10. Because when you are giving your answers, don't go quoting more decimal places than your equipment can measure to. Okay, so mine can measure to 21.10, so I've gone to 2 decimal places. If you start doing 2.643 or something like that, suddenly you're quoting an answer by calculation that is more precise than your measurement that you took in the first place, and you're not supposed to do that. So check the numbers that you're given to in the question and check the number of decimal places that you get with your equipment. That's how many decimal places you should quote to in your final answer. Always use the worst amount of precision. So always use the smallest number of decimal places of the equipment or of the numbers that you've been quoted. Part of the video is looking at how we can find the density of irregular objects. So these you can see have got little fiddly bits on them and slight changes in size. So we can't just measure their width, depth and height. we're going to have to find their volume in another way. And the way we're going to do it is using these volume cans, or we call them Eureka cans. You can see this one at the back here is dripping some water. You've got to fill them up all the way so that they leak water out of them. Okay, now catch the water if you can to avoid it making a mess. But the idea in these is that when it's completely filled up and it's finished dripping these last few little bits of water out, anything that we put into that can that sinks completely below the surface is going to displace the water. It's going to force the water out of that tube, and we're going to be able to catch that water in a measuring cylinder. Now, this is really useful because if we do that, the amount of water displaced by the object is exactly its volume. So that's going to mean we're able to calculate its volume and then find its density. I say calculate its volume, I'm just going to read it off the side. And then we can calculate its density. So that's pretty much done. So I'm going to tuck my measuring cylinder underneath. A slightly higher box would have been better so that it would stand up properly, but you know, these things happen. So I'm literally just going to plop this in the top. Because these things sink, it's not going to be an issue. I'm just going to be able to let it in. But if you've got an object that's buoyant and floats, you have to push it down under the surface so the whole thing is submerged. And that can cause inaccuracies, especially if your finger pushes in a little bit as well, because your finger will displace some water. So here we go. So you can see that is now pushing out some of the water, which is being collected in the bottom of my measuring cylinder. So you've got to wait till all of that water is finished dripping out, and then you'll be able to read off the volume. Now, just for the sake of this video, I'm going to try and speed it up a little bit. I cannot read it while it's angled like that, because obviously that would give me a very inaccurate reading. So I'm going to stand it up. And there we go. That is the volume of that mass. Final stage then. So what we're going to do now is always show our working. Density is mass divided by volume. It was a 200 gram mass, and its volume was 23 centimeters cubed. Just punch it in on the old calculator. 200 divided 23, which is 8.695. Now remember, in terms of using too many decimal places, this time the precision on my measuring equipment was probably only to about the nearest half centimeter cubed. So I'm going to have to round this, so I'm going to make it 8.7, and then my units are going to be grams per centimetre cubed. Okay, job done.